Okay, for the first question, it gives a function f equals to 5 plus 10x minus x squared, and on the domain -3 to 3. And the first question is to find the critical number or critical value of this function. So now we need to refer to the definition of the critical value or critical point. So it's on the chapter 4.1 slide page number 8. And it says if the first derivative of fx, so f prime c, equal to 0, or f prime does not exist for a given number c, and c must be in the domain of f, so this is the third condition, then c is called a critical point. So for either condition 1 or 2, we must have the first derivative of x. So we just need to find what is the first derivative of x. So take the first derivative of f, then which is 10 minus 2x. Because the first condition is set it to be 0, so we just set the first derivative to be 0. And after solving this function, we can find x equal to 5. But don't forget to check the third condition. The c must be in the domain of f, and domain of f is -3 to 3. But x equal to 5 is outside the domain -3 to 3. So it's not included in -3 to 3. So which means in this function, there is no critical value, so its critical value does not exist. And some people may wondering what does it mean f prime c does not exist. So this is usually for checking if a given condition is 1 over x, for example. Then we know for its default domain is x does not equal to 0. So in this condition, x equal to 0 is also a critical point or critical value. And the second part of this question is to find where is f maximum. So at which point we can find the maximum of the function and the minimum of function. So for this part, we need to apply the absolute extreme. So it's on the slide number 10. And the absolute extreme values, like extreme maximum or minimum, can only occur as a critical point or the endpoints of the domain. So, but from part A, we already know for this function there is no critical point, so we can exclude this condition. And now we just need to check the endpoints of the function, which is a equal to -3 and b at 3. So you can just plug in 3 and -3 to the function f and to see which one is a minimum and which one is a maximum. And for question 2, the given function is 3x to the power 5 minus 20x cubic, and interval or domain is -1 to 2. And the same, we need to find the critical value. So we know to find the critical value, we just need to set the first derivative function to be 0 and then solve the function. So the first derivative of fx is just 15x to the power 4 minus 16x squared. And then solve this function to be 0. And the common part for 15x fourth power and 16x squared, the common part is 15x squared. So we can put this term outside the bracket And for the first term, the left term is x squared, then minus 4. And x squared minus 4 is like a squared minus b squared. And we know a squared minus b squared is a plus b times a minus b. So what's left is just 4 is 2 squared, so x plus 2, x minus 2. So set this equal to 0. We can know x can be 0, x can be negative 2, or x can be 2. But are all these three the critical point? We have to check the third condition, which means the C or the values we found must be in the domain of f. What's the domain of f? It's negative 1 to 2. So among these three values, 0, negative 2, and 2, only 0 and 2 are in the interval of negative 1 to 2. In the domain of negative 1 to 2. X equal to negative 2 is outside of this domain. So here the critical values are only 0 and 2. And for the fourth question, the given function is f equal to absolute value x minus 3, and the domain is negative 4 to 4. And the same, we need to find where is the critical values. And from first two examples, we already know to find the critical values, we just need to set the first derivative fx equal to 0 and then solve this equation. But the function, it has absolute value sign, so we have to remove the absolute value sign. And we know from chapter 1, if a is greater than or equal to 0, the absolute value at a is just equal to a. But if a is less than is negative, then it's just negative a. So here we can check if x minus 3 is greater than 0, so which means x greater than or equal to 3. But don't forget it has to be less than or equal to 4. Then it's a positive number, so we just remove the absolute value sign directly. So if x belongs to 3 to 4, then fx is x minus 3. But what if x minus 3 is a negative number? So that means x less than or equal to 3. But don't forget it has to be greater than or equal to 4. Then it's a negative number, so it just becomes a negative x minus 3. So after simplification, it's 3 minus x. So now we have successfully removed the absolute value sign. So for x between 3 to 4, then f is x minus 3. So we can find its first derivative is just 1. Because x prime is 1, and 3 is a constant, so just a 0. And we noticed the first derivative fx is not 0. Then we can check the second condition when x between negative 4 and 3. Now fx is 3 minus x. So take the first derivative, it's negative 1, so it's still not 0. But we can notice that if I set x equal to 3, then f is just 3 minus 3. So just absolute value 3 minus 3 when x equal to 3. Then f is a constant 0. And for any constant, we know its derivative is always 0. So when x at 3, fx is a constant 0 and its derivative is 0. So the critical value, here is typo, so it should be x at 3. And for question 6, The given function is 4x over x squared plus 1, and the domain is -4 to 0. And now we need to find at x equal to which number we can find the absolute max, and at x at which value we can find the absolute minimum. So from the absolute extreme theorem, we know that the extreme values can only occur at either critical point or the end points. So first we can try to, here we already have the end points. So this is A, this is B. So A is -4, B is 0. But we don't have the critical point. So we need to find the critical point first. How to find the critical point? We just find the first derivative of x and set it to be 0 and solve the function x. And here, fx is a quotient form. So this is a quotient derivative. So after solving this derivative, we set it to be 0 and then solve this equation. We can find x can be 1 or -1. But at both of them the critical point, we have to check if they stay on the domain -4 to 0. And we can see that only x equal to -1 is on the interval -4 to 0. So here x equal to -1 is a critical point. So now we find the critical point is x equal to -1, and the end point A is -4 and B is 0. And we need to find where is the critical value. So the critical maximum or minimum can only occur at when x equal to either one of these three. So we can find f -1 when x equal to -1, when x equal to -4, which is f -4. When x equal to 0, that's f0. So plug in -1 to the fx. So 4 times -1 over -1 squared plus 1. So it's -2. And the same for f -4 is 4 times -4 over -4 squared plus 1. And the same for f0 is just 4 times 0 over 0 squared plus 1. And after finding these three values, we can see when f0 equal to 0, it has a maximum value. And when f -1 equal to -2, that's a minimum value. So the maximum x occurs at when x equal to 0, and the minimum occurs when x equal to -1. So that's a solution for 4.1.